Assalamualaikum and good evening. My name is Suraya binti Umar. I am a fourth year student of Faculty Manufacturing Engineering, BMFT, Section 3/1. My metric number is B0517101147. Today, I will make a presentation of PSM1. The title in this project is Characterization and Physical Properties of Recycled Rooftop Waste for Green Concrete Aggregates. In this slide, there will have introduction, problem statement, objective, scopes, literature review, methodology, and last is expected results. I will start first with introduction. Rooftop waste at the nearby industrial yard is plentiful. Rooftop waste is considered to have the ability to substitute natural aggregates and function as an internal concrete curing material. This is due to its porous nature, which requires the cement paste to be constantly supplied with internal water. However, owing to concerns about its durability and structural performance, the use of roof tile waste as aggregates in new concrete has also been limited. Although the capacity of roof tile waste aggregates to facilitate cement hydration has been suggested to contribute to an increase in compressive strength and a decrease in autogeneous shrinkage of the concrete produced, the overall result is not yet conclusive. This refers to the differential properties and features of the access of the roof tiles itself. Figure 1 shows the crushed roof tile waste that we will use in this analysis. Figure 2 shows sand and gravels or aggregate to make cement. Figure 3 shows the structure of cement and concrete. Problem statement in this project are: the toughness of the cement can be measured based on the replacement of the producing aggregates through waste ceramic. In this research, we need to study how tough the concrete produced are by using the roof tile waste in the analysis of the mechanical properties of green concrete. The porous nature in the cement paste that enables the continuous supply of internal water might affect the structure of concretes. In this research are to find how the internal water supply from the mixture of sand and gravels or aggregate contribute towards the microstructure of the hardened green concrete. Last, comparison of the data in order to analyze the best ways to replace the aggregates in producing the green concrete. Objectives in these projects are: first, to analyze the characteristic and physical properties of the crushed recycled waste roof tiles as an aggregate for green concrete aggregate. Second, to analyze the mechanical and physical properties of green concrete produced using roof tile waste. Third, to characterize the microstructure of green concrete produced using roof tile waste. The scopes in these projects are: to study on the characterization and physical properties of the recycled roof tile waste. Second, study on the mechanical and physical properties of green concrete produced using roof tile waste. Third, study on the microstructure of green concrete produced using roof tile waste. Next will be literature review of in this project. In this project, I have found 3 articles that directly related with the objective in this project. First article is release of internal curing water from lightweight aggregates in cement paste investigated by neutron and X-ray tomography. The parameters in these articles are water to cement ratio, which is 0.25 pounds. Cement used was Portland cement, which is CEM 142.5 with density of 3,130 kg per meter cube. The blade fineness is 2,800 cm squared per gram. A polycarboxylate-based superplasticizer, which is solid content 30% by mass, added at a dosage of 0.72% by mass of cement. The ionized water was first boiled for about 15 seconds. Afterwards, cooled down to ambient temperature before mixing. The mixing was performed in a vacuum mixer, which is twisted evaluation, for about 2 minutes. Figure 4 shows the properties or behavior that we can find in this article. Figure 4 shows the release of water from lightweight aggregate in the hydrating cement paste, donor, which is blue, and recipient, which is red, domains in the sample of cement paste with lightweight aggregate based on subtraction image of the corresponding vertical cross. The second article, which is impact of mechanical resistance of aggregate on properties of concrete. The parameters used in these articles are, first, set types of aggregates as well as ordinary concretes of 0.55 pounds ratio and high performance concretes of 0.3 pound ratio. All crumble piles of individual aggregates were formed from separate fractions, which is 2:4, 4:8, 8:16 millimeter. For concrete with all aggregates, Portland cement was used with properties consistent with EN 197.1. Mixture of polycarboxylic ether and calcium lignosulfonate with ratio 0.30 pounds. The consistency index of all the concrete mix is equal with 12 plus minus 3 cm. The principle of maintaining the same volume of cement paste in 1 meter cube of the mixture was adopted. The content of cement, water, and sand in mixture with the same pound of ratio was constant, and last, the same volume of coarse aggregates in the concrete. Figure 5 shows the properties or behavior that we can find in these articles. The surface figure shows the surface of a cracked concrete specimen with gravel. For figure A, we can find 1 is sandstone, 2 is limestone, and 3 is transverse crack to surface in aggregate grain, and 4 is exposed basalt aggregate grain. In figure B, we can see 5 and 6 is a transverse cracks to surface in aggregate grain, and 7 is traces of detached grains. In the last articles, which is mechanical properties of recycled aggregate concrete under compression shear stress state. The parameters used in these articles are the Portland cement, which is 142.5, and river sand. The finest modulus of the sand is 2.67, and water cement ratio is 0.43 pound, combined with 3 kinds of RCA replacement rates, which is 0%, 50%, and 100%, and 5 sets of compressive stress ratio, which is 0, 0.2, 0.5, 0.6, and 0.8. The water dosage consists of 2 parts. One part is normal water, which calculated by common concrete mix method, and the other part named additional water, which determined by water absorption of recycled coarse aggregate. Figure 6 shows the properties or behavior in this that we can found in this articles, which is failure patterns under the compression shear stress. Next slide is methodology. In this project, there will have 5 phases in the analysis. Phase 1 is raw materials and preparations. We will use roof tiles waste collections and crushing using a crusher machine. The roof tiles waste collection is from the Golden Clay Industries in Heights. Phase 2 is a crushing analysis. We will do a crushing analysis where we will make a sieve analysis according to standard to obtain curve and fineness modulus, and we will also make an aggregate crushing and value determination. In phase 3, we will make a physical properties, compositional and structural analysis. We will do a specific gravity test, water absorption test, abrasion resistance, composition analysis via SRF analysis, crystalline phase analysis using SRD. In phase 4, we will do a slump test of green concrete mixture to analyze the workability of fresh mixing concrete and to utilize coarse recycled roof tile waste aggregates and fine recycled roof tile waste aggregates with different mixture ratio. In last phase, which is phase 5, we will do a structural analysis of the hardened concrete, where we will make a crystalline phase analysis using SRD and morphology analysis using SEM. Figure 7 shows the raw material that we will use, which supplied from the Golden Clay Industries in Heights. To prepare the concrete, we refer to British standard, which is BS standard, where the use of suggestion method of ratio designs, which is mixed design of concrete, compares to DOE method, BS standard. Application of green concrete. Figure 8 shows the green concrete that applied at the main homes. Figure 9 shows the green concrete applied at the ground floor slab. Figure 10 shows the green concrete applied at the carport. And figure 11 shows that green concrete applied at the drainage. In the last slide, the expected results will be to obtain the data of the gradation and the fineness modulus of the crushed roof tile waste from the sieve analysis. Second, level of crushing roof tile waste aggregates value determined. Third, obtain the specific data of the roof tile waste aggregate after doing the gravity test, water absorption test, and abrasion resistance test. Fourth, obtain the data of the coarse and fine aggregates at different green concrete mixture ratio. Figure 12 is the example of SRD analysis for crystalline phase. Figure 13 shows example of morphology analysis for hardened concrete, and figure 14 shows the example of SRF analysis for composition analysis.